This is it, isn't it? This is how I'm going to die. Well, I'll die the way I lived, off balance and poorly thought out. Hello, Internet. My name is Quinn, and this is Blondihacks. It's a big day here in the shop. I'm starting a new engine build. This is not your typical model engine, though. This thing is something special. So let's go. Well, here we go again. It's a model engine casting kit, but this one is a beast. That's 60 or 70 pounds, I think, of cast iron in the box. Look at the size of this thing. This is the PM Research steam engine number 4, which is the vertical version of their big quarter horsepower number 6 engine. Now, technically, this is not actually a model engine. This is a copy from the original drawings and castings of an engine offered by the Chas A. Streelinger Company of Detroit, Michigan in 1895. And this is actually a real accessory engine that was sold to like farmers, for example, to run a cream separator or maybe a small drill press, small mobile accessory power for those types of applications. So this is a real engine, not a model. Now, the question is this engine too big to machine on my very small machine tools? And the answer is maybe. This project is going to be an exercise in pushing my machines to their absolute limit. So if you are interested in seeing how far you can push your machine tools, this is the series for you. Let's get going. Something I learned on my last project is that you're going to be living with the drawings for a very long time, 6 months, a year, maybe even more, depending on how much free time you have. So this time, instead of having those drawings occupy half my bench all the time, I've decided to hang them up here in an empty space in the shop, which gives me the chance to pretend I understand what I'm looking at and perhaps have grasped some clever inside joke by the draftsperson. I see what you did there, Gary. Good one. I'm going to start with the frame because I think this is going to be the most challenging component. If I can't machine this, then we're doomed. It's really important to pick a main reference for all of the motion works on an engine like this. So in this case, the center line of this bore, the crosshead guide bore, is, I think, a really good choice. A cylindrical feature is a great choice for a reference because there's lots of ways to indicate it and reference it. So that's what I'm going to use. It's a 1.5 inch bore all the way down through the top part of this casting where the crosshead slides up and down. How am I going to create that bore though? This thing is not even close to fitting in my mill. I mean, the casting doesn't even clear the spindle, never mind having room for tooling and fixturing and so on. So the mill is right out. You might consider mounting it on the faceplate and spinning it up like this, and I did consider this. However, there are some build logs on the internet of this engine, and I know at least one person who broke the casting doing this, sending it flying across their shop. Terrifying experience. Nor can I fixture it the other way, which wouldn't allow me to clear the legs with a boring bar. For me, I think the answer is line boring. I'm going to fixture this casting on the cross slide. The compound won't be there, of course. With line boring, you can feed the work back and forth with the carriage, and then you've got a long cutting tool running in the lathe. So that's what I'm going to try. Now, before we get to that, I got to clean up the casting, or fettle it, as the Brits like to say. A feature like this is all about getting it centered aesthetically on the casting. It doesn't really matter where that bore is as long as it's within, the casting material. But for the engine to look good when you're done, it needs to be visually centered on all the parts of the casting that will not be machined. Let me illustrate what I mean by that. Here's a crude model of the frame that we're machining and the base and the main bearings there. So this is sort of the ideal version of the machined castings. Now let's put the motion work in here, or a representation of it in peach there. That's the crosshead, and then theoretical linkages down to the theoretical crankshaft. So this is the ideal if everything is machined perfectly. Now what happens if we machine that crosshead bore at the top off by a little bit, say 1/2 degree to one side? It's a little crooked. So you might think, well, the engine won't run now, right? Well, no, this doesn't actually matter, because although the crankshaft at the bottom there now looks misaligned, it isn't really, because what we're going to be doing is machining everything relative to that bore. That's our reference for all the motion work. So really what's going to happen is the mechanism is going to end up shifted over to the right, assuming the bearings can't move. This is a hypothetical example for castings whose relationships you can't change. So now you can see what happens here is everything is aligned mechanically. It's just that now the crosshead is running a little crooked in the bore relative aesthetically to the casting. but the engine is still going to run just fine. So we're creating this virtual negative space engine, if you will, shown in peach, within the space of the castings. The point is, if you don't get this perfect, it's not the end of the world. The engine is still going to run just fine as long as you machine everything relative to that same first reference. This piece has been cast with a core in it that's much smaller than the final bore will be, so really we can just kind of pick our location here and what will look good. All the basic cleanup I'm doing with a rotary tool and these little cheapo grinding drums that you can get on eBay, and they work just fine. The goal is to just smooth out all of the casting lines where the cope and the drag meet and any other imperfections on the casting. This is not just aesthetic. In order to set up these initial features, we need to be able to indicate on these castings. And of course, a rough casting is a terrible surface to indicate on. So we need to try to even out the surfaces as much as we can and unify the shape. If we're trying to center something on a cylindrical part of the casting, we need that cylindrical surface to be roughly cylindrical in shape. Inside the legs here, I've got a great big chunk of cast iron there, which looks like that's probably where the gate was for this casting. So that's too big for the Dremel, so in comes the big guns. I've got a grinding disc here, and angle grinders are well known for their delicate precision work, so this was quite easy to do. That got me into filing range there, so I could finish up the job here with a file. And that is all looking nice and smooth now. The goal is to get the surface even by feel with the rough textured surfaces on the sides. And I got to the edge of the leg there a little bit with the file, but let's just keep that between us, okay, Internet? I'm doing one additional step that I did not do on previous casting kits, and I'm using a flap wheel to grind the worst of the scale off of areas that are going to be machined. I've learned the hard way that machining through that scale on small machine tools is really difficult. The standard advice is to take a heavy cut on your first pass to cut under that scale, but you can't on small machines, so you end up having to chisel your way through it a few thousandths at a time, and it's brutal. So since there's lots of extra material here to machine anyway, I'm just grinding the top surface off of it, and that'll get rid of all of the sand and the grit and any glass hardness that's in that outer layer of the casting. That all makes a frightful mess, so I gotta clean up before I go any further. Cast iron is messy stuff no matter what you do, and grinding it is 2x messy. There's the final casting, all fettled and machinable surfaces cleaned up with the flap wheel, so I think I'm ready to start making chips here. Let's get this thing set up over on the lathe. In a previous video, I made a line boring tool and did some test cuts on it, so I made sure that this idea was going to work, and it will, so I'm just getting my casting here set up in a way that's going to give me clearance for the casting on both sides of the cutting tool, and also the legs need to clear the tailstock there. Once again, in the spirit of getting rid of the scale before I machine, I threw some 80 grit sandpaper on the boring bar here before I do the actual machining, and I thought I'd see if I could just kind of sand the scale out of the inside of that bore, and honestly, I don't think this worked that well. Maybe it helped a little. I couldn't run the lathe too fast because it was pretty grabby and I was afraid about the safety of doing this, but maybe it helped a little. It made a mess at least. To prepare the line boring tool that I made in a previous video, I'm getting my high-speed steel tool bit set up there. I need to cut it shorter so that it'll fit inside the bore here. I need to be able to install and retract the bar without touching the work. So this tool bit needs to be shorter, and then I ground a normal right-hand turning tool profile on that. 0 lead angle and a little bit of nose radius gave me a really good cut, so I think this should work. Now the hard part, to fixture this thing on the cross slide. So off comes the tool post and the compound, get everything cleaned up there. I've actually never had the compound off of this lathe before, so there's some factory goo and chips piled up under there. And I got some T-nuts that I made here for the cross slide to fixture on. Now, the first thing I tried was a couple of 1-2-3 blocks and some parallels because it looked about right height-wise. And I'm using the square side rails there of the crosshead slide casting area. This looked like an easy way to fixture it with some blocks and some jacks and some clamps. And this was looking pretty good until I put the indicator on it. And yeah, those ribs are super, super tapered. So this is no good. The thing about a casting is that there tend to be angles on them everywhere. Some of those angles are aesthetic and some of them are draft angles that allow the part to be removed from the sand casting. But point is, you got to check anything that you want to use as a reference for angle. But I did find that the round ribs on the other two sides of that center area are straight, as are the flat areas on either side of those ribs. So using a V-block, I'm able to reference those flat areas around those ribs and get the casting to sit reasonably flat. Now I really needed my clamping bolts to be inboard a little bit of where the T-slots are, so I made this crossbar here out of some 1/2-inch steel bar stock, and it has a T-nut-like connection in the center there. You can see the peening over of the bottom of those threads, and this clamps firmly down onto both T-slots and then allows me to have threaded rod come out in 2 different places in locations that are correctly spaced for this casting. And then I'll keep those bars because I can later add holes to it for other types of clamping jobs on the cross slide. Now I need to get that casting boss at the top there centered aesthetically as best I can on the spindle. So I'm using a coaxial indicator in my lathe spindle for this. You could do this with a DTI as well. You don't need such a fancy tool, but I have it, so I'm going to use it. So I start by getting it centered forward and back using the cross slide because that's easy. So I'm going to do that and then lock the cross slide. Now getting it vertically. This is where the real work is in a setup like this. So it needs to come up a little bit, and a feeler gauge under the indicator there can tell you how much it needs to come up. And it's good to know that up front because it's kind of a lot of work to tear down this setup, pull everything apart, add some more shims underneath your blocks, put it all back together, clamp everything down, and check it again. So this is a slow iterative process, but you have to go through it to get the height right. You could also mount the casting to a vertical angle plate, and that would give you easier vertical adjustment, but I didn't think that setup was going to be rigid enough, so I went with this approach. After a few iterations of that, I got it to this point here. Now those ticks on the indicator are 1/2 thousandths, so I'm within about 5 thousandths here of being perfectly coaxial, which, you know, on a casting, which is itself not particularly round, is pretty good. I'm pretty happy with that. But now comes the hard part. I have to get the whole casting straight along the axis of the lathe, and there are no references to use here anywhere. There's nothing straight. What I decided to do is actually put the line boring tool in there and reference the casting to the bar itself. And I'm just using a depth micrometer there to compare left and right, and then I'm just tapping it in until I get the same reading on both sides, so that hopefully the bore is then running straight through this casting, coming out the same distance forward and back on the back side. If I achieve that, it should be pretty darn close. Okay, that was multiple hours of setup, but it's time to touch off with the tool. So I slide the casting over and then push the tool bit out until it touches the surface and pull it back, and that's touched off. And now I can dial in some depth of cut. There's a lot of taper in the bore, so I know the bottom will not start cutting for quite a while. The top of the casting bore is much, much smaller, but I'm just doing 10 thou passes to start. And so I'm using an indicator there to set the tool offset, and away we go. So I started feeding this through with the cross slide on a very slow feed rate. I'm running the lathe at 250 RPM, which should be about the right surface speed for cast iron, but that is pretty slow, and so with a slow feed, this is a very slow process. Each pass here was about 10 minutes, and I had about 250 thou to take out of here, so this was not fast. This took a lot of patience. It took a few passes before I had the whole bore engaged because, again, there's a lot of taper in that bore. It's clear there was draft angle inside there. But the cool thing is with that window in the casting where the crosshead rides, we get a little window into the action here of the line bore. This is a very cool operation. This is my first time ever doing this, and it's really a lot of fun. It's really cool to see how it works. It's pretty tedious once it's time to start measuring because you have to remove the bar so that you can get access to the casting without messing up your setup. So I should be fairly close, and I'm checking the dimension at both ends with telescoping bore gauges, and wow, there is no taper in that. So already I'm impressed with the accuracy of line boring. Then you got to feed the bar back in, dial it in again, set up your tool bit once again, and start making passes again. I'm driving the line boring tool with my 4-jaw chuck. I know that sometimes people will do it between centers, but I was concerned that wouldn't be rigid enough given how long this bar is. The bar has to be really long in order for the legs to clear the tailstock at the far end there, so not a super rigid setup, and I stuck to 10 thou passes all the way down. My Noga material detector confirms that this is in fact cast iron. In this shot from the back, you can see the wavefront of the cut moving down the bore as it goes, which is really cool. And it sounds really cool when you've got full cutter engagement all the way around. Okay, that should be the last pass. take the bar out for hopefully the last time and see how we did. There's the bore. It looks super well centered aesthetically on the casting, so I'm very happy with how that came out. The top is harder to tell because that cast boss is really out of round, and so I think center on the top here is wherever we say it is. We have quite a bit of material to machine off of that yet, so it'll be fine, I think. The surface finish in there is okay. It's not outstanding. It certainly will hone up nicely, I think. It's not as nice as the freaking miracle that was the steel test piece that I did. I don't know what I did right there that the finish was so good, but dimensionally though, really happy with that. I came in at the high end of my tolerance, so I pushed my luck there, but we're within a couple of tenths of there being no taper in that bore, so really happy with that. Line boring is very impressive. So this went great, right? Nothing went wrong. Well, Metallicor, the god of machining, demanded a sacrifice on this one, folks. My carriage now has a very big, tight spot every 4 turns or so. So what happened? On one of my passes, I wasn't paying enough attention and the carriage fed too far to the right and the casting collided with the tailstock. And you can see the mark on the paint there. And it was powerful enough that it pushed the tailstock back, even with it locked, and caused the boring bar to come loose a little bit on that end, which amazingly caused no damage to the work. And the casting wasn't damaged by that crazy pushing operation that happened. And on top of that, somehow the setup didn't move. So I was able to finish the operation. I had one more pass to do after that happened, and nothing was affected on the part or the setup. So all in all, not a terrible result, but I am going to have to now tear down that carriage and figure out what I bent. Probably the drive pinion, something like that in there is damaged. But I honestly prefer that that gave way rather than my part or my setup, because I have at least 2 days invested in this one operation at this point. But I'm going to get a lot of mileage out of this setup, which is great for how expensive it was to do, because now I need to face the end of that cast boss. So my first thought for this was just to put the fly cutter in the lathe and run it across there. And unfortunately, I don't quite have enough travel on my cross slide to do this. I could have done it if I'd planned ahead and positioned the casting in a different place, but I didn't think about it. The casting is sitting in an arbitrary spot, and even with the fly cutter choked all the way up, it won't clear both sides of the cut. So I have a sneaky plan B. I brought in my 2-inch face mill and line this up on there. And I'm going to run this down the middle of the stock all the way across. And of course this doesn't cover the whole boss, but stay with me here for how I'm going to finish this up. This thing did great on this cast iron. It really chewed through there. I could take pretty heavy depths of cut. You can hear how happy it is slicing through that cast iron. So I machined the center section here down until the thickness was within tolerance on the drawing. It's still a cast boss on the underside, so there's plenty of tolerance on that on the drawing. Then I swapped the face mill out for the fly cutter again. And watch what happens here. With the fly cutter choked all the way up, the section removed by the face mill on the left and right gave me the travel that I needed so that the fly cutter can now cover it, because our circle is now a pill shape, if you will. And that was all I needed. I just needed that little bit of extra help. And now I can finish it up with the fly cutter to catch the top and bottom. Now the fly cutter is a lot slower than the face mill. It's not as rigid. It needs a lot more help. So I'm doing light passes here and a lot of them. There was a lot of material to remove off the top of this boss. So this was 10 minutes per pass, and I think it was 20 passes, something like that. So thank goodness for power cross feed, because this was definitely a hurry up and wait sort of operation. The key here is that I'm machining this top face in the same setup that was used to do the bore, and that ensures that the two are very, very square to each other. This is one of the most important things on a steam engine. The cylinder mounting has to be extremely square to the travel direction of the cross slide. That's really critical to the engine running well, so do them in the same setup if at all possible. But oh golly, Miss Molly, that fly cutter did a nice job. I wish you could feel this finish. If you're watching on a CRT, feel the glass screen. It'll feel about like that. You can almost read the scale in that, which for gray cast iron right off the tool is pretty remarkable. Fly cutters are amazing. But wait, there's more. I also need to turn the OD of this boss, and I'd like to do that in this setup as well because, well, I don't have any other way to do it, frankly. I forgot to grind the scale off that surface earlier, and I hate to grind on the lathe, but luckily I have the standard Dremel dust collection attachment here, so I installed that per the instructions, and I just very carefully ground the scale off of this in situ without disturbing anything or getting destructive grit on my lathe, hopefully. To turn that OD, my thought is to use the boring head. Now, this is my standard 2-inch boring head for my mill, which has an R8 shank on it. So I picked up a straight shank and swapped that in there, and that will allow me to easily put it in a collet in the spindle. I'm going to start with my coaxial indicator here to get the bore centered up again. After facing the top there, the cross slide was in a random place, so this is an easy way to get it back on the center line there. The only dimension I need to modify, of course, is the cross slide because I haven't touched the vertical position, so that was easy to dial in. Now in comes the boring head. Unfortunately, the shank is a little too long for my collet chuck. I can't get it very deep. My collet chuck doesn't have a through bore, but we'll see if we can make do here. Crank it all the way out. Uh-oh. Poop knuckles. My boring head does not have sufficient reach to do the OD of this boss. Well, that is disappointing. And I thought a long time about what to do about this problem. If I'd planned ahead sufficiently, I could have made a special purpose tool for this, like a kind of one-off boring head, if you will, that just had a slot to offset the tool. But I didn't, and I was stuck in this setup, and I couldn't move anything, so I had to buy my way out of this problem. And I dipped into the Patreon kitty and picked up the cheapest import 3-inch boring head I could find. The cutter I'm using here is a left-hand boring bar, and I've cut the shank down to fit in the boring head here nicely. This is a brazed carbide tip boring bar, so the shank on it is mild steel. It was easy to cut, no harm done there. And luckily, this bigger boring head has plenty of offset to turn this. So I start by touching off. I'm just very slowly turning the cutter by hand and bringing it closer and closer to the work until it starts dragging on the material. And I'm also checking for clearance here on all of my clamping bars and things. It's very close and very tight in here. Because of that, I'm setting up an indicator on the carriage because the stopping point of this cut has to be dead nuts. There's no wiggle room here. And away we go, and uh-oh. Yeah, immediately trouble. You hear that chatter building? This is trouble. This setup is just not rigid enough for doing what I'm trying to do here. So, well, I thought about this for a while, and here's plan B. I took the shank off of the boring head and just chucked it up in the forejaw. I dialed in the body of it, reset my offset, and away we go. And this made all the difference. This is the rigidity that this setup needs, and now it's cutting beautifully. You can hear the difference there. This is still a partial cut, but it sounds so much better. Now you might be worried about the offset mass swinging around on a small lathe, and I certainly was, but the good news is this is only turning at 140 RPM. Because of the large diameter, it doesn't need a lot of RPM to get the correct surface speed for cast iron, and so the lathe is perfectly smooth because it's turning so slowly. And once it's on a full cut, just listen to how good that sounds. I'm using an exotic offhand boring bar here, but you could do this with a regular boring bar, but you would have to run the lathe in reverse, and I know from experience that long, hard cutting operations on this lathe in reverse tend to overheat the motor, so that's why I went with this one. Once again, I did this in a lot of light passes. I probably could have taken pretty heavy cuts with this setup now that I got the rigidity sorted, but it was working really well, and each pass is so short that doing a lot of light passes really didn't take that long, and I didn't want to push my luck. If it's working, just leave it alone. I had no trouble really nailing that dimension. It's a shame that, honestly, that dimension doesn't really matter because, man, I nailed it. Oh well, it's still satisfying. I made sure to retract the cutter before I pulled the part out so I don't drag it across the work. I'm not gonna lie, I had mixed feelings about pulling apart this setup because it's been up that way on the lathe for 2 weeks now, maybe more, because it took a long time to do all this and I was waiting for tools and parts along the way, and yeah, it was a hard-earned setup, but I got a lot of mileage out of it. So then I just had to do some deburring on the bench, and the end result is really outstanding. I'm honestly shocked with how well this went. Aside from crashing the lathe, this couldn't have gotten better. You can see how big this thing is once again. Wow, I can't believe I machined something that big on my equipment. But we're just getting started on this engine, so subscribe so you don't miss any parts, and stay tuned because it's going to get even crazier. Thanks for watching. Thanks to my patrons for making all this possible. And I'll see you next time.